Look, we're live. We're going live. Okay, so I've got to teach y'all today, so y'all got to listen. All right. So it's real important that y'all listen and pay attention because we're learning about slopes of parallel and perpendicular lines. That's our lesson today. Okay. And then you're going to have 2 assignments from Buzz. Both 5-question assignments. They're both on Teacher Made. I mean, like they're on Buzz. You click the link, get your worksheet, right? They're all multiple choice. Okay, but you do have to pay attention because last hour, first period, they were doing it, and I kept having to send them back to them because they weren't paying attention to what the question was. Okay, so let's talk about first parallel lines. Now, y'all actually know this from Algebra 1, but I bet you don't remember it. Do you remember anything about parallel lines and their equations from last year? Anybody? Okay, it's okay. That's why I'm here. I get paid the big bucks to remind y'all about stuff you already know. Okay, so I'm not going to complain about my salary. I make a good salary for this area. I'm not ever going to complain about it. But teachers do not make a lot of money. But I'm just saying. All right, so parallel lines, right? Y'all, that's pretty good. I'm just saying. That's pretty good. If we're talking about equations of parallel lines, equations, we know from this past week we've been discussing, we're talking about slopes, y-intercepts, right? What about these 2 lines jumps out at you when you think about their equations, and if you're looking at them on a coordinate plane, something that may be, I don't know, the same, they are both positive. They both have positive slope. Could it be more than just being positive, though? They have the same distance from each other for sure, right? So, and it would be a lot better if I had these on an actual coordinate plane instead of just sketched on this paper. But what if I count slope here, and I go, say, up to over 3? So my slope is 2 over 3, right? Well, guess what? So is that one. Parallel lines have the exact same slope. Parallel lines have the same slope. Okay? So if the slope of one line is 4, any line parallel to that line, the slope will also be 4. If the slope of one line is 10, any line parallel to that line, the slope will also be 10. If the slope is 1/2, any line parallel to that line, the slope will also be 1/2, right? Now, I do want to point out one thing about parallel lines. They can't have the same y-intercept. Because if they have the same slope and the same y-intercept, they're the same line. That's not parallel, right? I will also say Buzz is an idiot and sometimes says that they're parallel. I think they just didn't pay attention to what the y-intercepts were. And so they were like, oh, yeah, those are parallel. But they're not, okay? Same slope and same y-intercept cannot be parallel. Same slope, different y-intercepts, okay? Y'all with me? All right, I need to pull up some practice problems because I am terrible at making them up. So give me a second. Wrong place. So this is in lesson 25. Yeah, in lesson 25. Of course, they have the read it, they have the watch it, and then we're going to look at a few practice it problems. Okay, look at this real quick. Let me switch this over on... Okay, so if we're looking at this right here, and it says identify lines that are parallel to y equals 5x plus 2. Which of these lines are going to be parallel to 5x plus 2? This one says y equals 5x minus 10. Yes or no? All right, let's back up. What is the slope of this line? Y equals 5x plus 2. 5. Not the x part, just the 5. Okay? What is the slope of this line right here? So guess what? They are parallel, right? Is this one also parallel? Could there be more than one parallel line? Yes. Is this one parallel?
No.
Nope. Is this one parallel? Nope. Can there be more than one? Yes, there can be more than one. Okay, so look at these. Oh, look at these, y'all. How are we going to tell if they're parallel? Well, we're looking for the slope, but these are in standard form. They're not in slope-intercept form. So guess what we have to do? We have to put them in slope-intercept form to see what the slope is. So if you're going to, let me write them down real quick so I can switch over to the other screen. It's not 1. So you know that one is not 1? Okay, that is an accurate statement, but that's not the reason it's not 1.
Well, it's because 4 and 4 is supposed to be.
One's a positive, one's a negative.
Oh.
Okay, so I wrote them down. This is what we're looking for. That right there, right? But these are not in that format, except for this one, and we've already figured out that one's not, because it's not a negative. But I do like that you caught they had the same line intercept, so it couldn't have been if they had both been negative. They would have been the same line. But before we can say what this slope is, we've got to put it in slope-intercept form. So we're going to have to subtract 30x, right? Because we want it to look like this. We want it to look like y equals mx plus b, right? So that's going to give me 15y equals negative 30x. I want to put my x first. Negative 30x plus 60. And then I'm going to divide both sides by 15. Right? So that's going to give me y equals negative 2x plus 4. Is that right? Mm-hmm. Yeah. So now, is this one parallel to this one?
No.
No. Why is it not parallel?
Because it has plus 4.
It has. They both have the same y-intercept. These are the same freaking lines, y'all. Remember, parallel lines don't touch. If they're the same line, they're touching everywhere. Right? They're not parallel. Buzz says they are, by the way. Buzz is wrong. They are not. And I think all Buzz did was be like, oh, they got the same slope. Yeah, I'm done. Right? Because you could stop just by dividing by 15 right there and be like, oh, same slope. Okay, look at this one. So we've got to get this one. We're going to add 4x to both sides. Right? And that's going to give me 2y equals 4x plus 8. And I'm going to divide by 2, divide by 2, divide by 2. Guess what I've got here? Y equals 2x plus 4. Is that parallel? No. Why not?
Because that one's positive.
That one's a positive. So that's two lines that do this. They cross, right? They cross because they have different slopes, but they're not parallel. Okay, so then we're going to subtract 6x from both sides. And that's going to get me... We're going to divide by 3. And y is negative 2x plus 4. Is that one parallel?
No.
No, why not?
Wait, so there's no way.
None of them are parallel. None of them are parallel. So if this were the case, if you were doing this and this were the case and none of the answers work, then just none of the answers work. You know, this is one of those pick all that apply. None of them apply. Now, are you going to see that on like a test? No, you're not going to see that on the test. But just know that in real life, sometimes the answer is none. Like sometimes that's the case, that there is not an answer that fits, right? Of what you have available to you. Okay? So that is what it looks like if we are, if we're just comparing them, right? But what if I ask you to write one? What if I want you to write the equation of a line? So let's say I give you y equals negative 5x plus 1. And I say that I have a line that's parallel to that line but goes through the point 0, 3. Okay? So it's parallel.
Why don't you just split your screen?
This Elmo won't let me split the screen. You know I could split the screen with the document camera? Well, the Elmo won't do it. It won't do a split screen. So, yeah, old technology. So we've got this, right? And I know it's parallel to this line. So if it's parallel to this line, what do I know about lines that are parallel? Same slope. So what's the slope of this line right here? Negative 5. So that means the slope of my new line is negative 5, right? And I know my line goes through this point where x is 0 and y is 3. Whoa, x is 0? Where is that located? On the y axis, which means that is my y-intercept, right? If it's on the y-axis, that is the y-intercept. So that's going to be y equals negative 5x plus 3. Because they gave me the y-intercept. I don't have to do any special math. I don't have to plug it in to any special equation. I'm done. Like that's it right there. Right? Okay. So what if... Can y'all see that good enough if I do it like this? Or does it need to be bigger? I might be able to just... If I don't move it, if I just lay it on top, I may be able to do it like that. Okay. So... And anybody who watches this video is going to be like, what is she talking about? Because I've got their screen set just to be the Elmo. Y equals 5 over 3x plus 2. So it's parallel to this, and it goes through point 2, 1. Okay? Parallel to this means they have the same slope. What's the slope? 5 over 3. So my new equation... Ty, come sit on this boat. Come sit on this boat. I think it's a roach. This is the reason I want you to step on it.
Where?
Right there.
Kill it.
Kill it. I don't want my classroom to have roaches, but I sure don't want to carry any home to my house. Okay. So, our new equation will have this slope. Now, this time, they didn't give us the y-intercept. They gave us a point. They gave us an x and a y value, right? So we're going to use point slope form. Remember point slope form? Y minus y equals m times x minus x. And we're going to plug our slope into m. We're going to plug our 2 into the x. We're going to plug our 1 into the y. So it's going to be y minus 1 equals 5 over 3 times x minus 2. Does everybody see where I got that from? Everybody? Okay. So, now, if they ask for it in point and slope form, we're done. That's it right there. But no, most of the time, that's what we want. Most of the time, we want to go ahead and put it in slope intercept. So, we're going to multiply this out, right? We're going to have 5/3 x minus 10/3. And then we'll add 1 to both sides, right? So y is going to be 5/3 x. 1 is the same as 3/3. 10 minus 3, that's going to be minus 7/3. Just for the sake of us getting through this a little faster, I'm just sort of doing the math for us, okay? Normally I don't do that, but we're sort of on a time crunch today. Because yesterday we did not do what we needed to do. All right? Everybody good with that?
Yeah.
Okay. So if you look at one that looks like this, and it says y equals negative 1/3 x minus 7, and it passes through 5/3, right? So we know it's parallel to this one. It goes through that point. What's our slope? This is our x value. That's our y value, right? So we'll do y minus 3 equals negative 1/3, that's our slope, times x minus 5. That's the equation in point slope form. But if we want to put it in slope intercept form, we got to multiply, do that distributive property, and then move that minus 3, right? So we're going to have negative 1/3 x, positive 5/3, right? Add 3 to both sides. Which 3, that's going to be 9/3. 9 plus 5 is what, 14/3? And that's our answer. Okay, parallel lines. Not hard, right? Not hard. Now, perpendicular lines. Tell me what you know about perpendicular lines. 100%. So 2 lines that cross at 90 degrees, right? That's perpendicular lines. I'm going to sketch some perpendicular lines on here. I'm going to do the best I can, but we all know my sketches don't always go right, right? So there's one. I think that's pretty good, y'all. That's pretty impressive, actually. Those lines are relatively straight. I'm pretty proud of myself. Okay, now, we know they cross at 90 degrees, but I want you to think about them in a coordinate plane. So in a coordinate plane, like we can find slope, we can find y-intercepts, right? We can find x-intercepts, all that stuff. Are they going to have the same slope like parallel lines do? No. I mean, clearly, one goes like this and one is like that. So one goes positive and one is negative, for sure, right? So, but it's a little more than just that. They also, their slopes are the complete reciprocal of each other. So like if the slope of this one, I'm going to make up a number, okay? So like if the slope of this one is 3/4, right? Then the slope of this one is going to be negative 4/3. They are what are known as opposite reciprocals. Reciprocals. So opposite means the sign. I'm pretty sure I spelled opposite wrong. Opposite means the sign. Reciprocal means we flip it over. Okay? So like if a line's slope is -2/3, perpendicular to that would be positive 3/2. Right? Y'all see what I'm saying? Y'all with me? If I have one that is 4/5, what would perpendicular to that be? -5/4. If I have one that is 1/4, what would perpendicular to that be? -4/1. Do I have to put it over 1? Not unless I'm graphing. If I'm graphing, I need to put the over 1 part. But if I'm not graphing, I can just say -4. Which leads me to this. What if I had a slope of 2? What would be perpendicular to the slope of 2? You're almost right. 1/2. Now remember, we've got to flip it. So that means that this has to be a fraction. How do we flip? How do we make 2 a fraction? 2/1. So when you flip it, it's 1/2. Does that make sense? So like what's the perpendicular slope to 3? What's the perpendicular slope to -3? I didn't say negative, my bad. -3 would be positive 1/3. See how that works? Right? Okay, so if we have a question, I'm not in the right spot. So I'm going to switch you over to this real quick. I'm going to switch you to Buzz. Quickly. So, are these lines parallel? Are they perpendicular? Or are they neither? Neither would just be they're just intersecting lines. Neither. Let's talk about why. What is the slope of this one? What's the slope of this one? So they're not the same, but they're not opposite reciprocals either, right? So they are neither. What about these two? Wait, that's not the right thing. Hang on. What about these two right here? Parallel, perpendicular, or neither? They are perpendicular. One's 2, one's negative 1/2. That's opposite reciprocal. So they are perpendicular. Okay? What about these two?
No.
That's probably
It's parallel. Isn't it parallel since the line?
Technically, it's parallel in this, but like it's not.
They are actually parallel.
Oh, because you have different ones.
They have different y-intercepts. They have the same. Yeah, you were right the whole time. I was just seeing if you could convince everybody. They have the same slope. Negative 1/2 is their slope. And their y-intercepts, although they look the same at first glance, one's a positive and one's a negative. So yes, these two are parallel. Okay? What about these two? Perpendicular. What about these two? Neither. Why are they neither? Yeah, one of them has to be a negative. They're not both negative. One of them's not a negative, right? So they're neither. Did we get them all right? Look at us. Woohoo! We did good. Okay. What if you have information like this, though? So what if we say, like number 1, it says one line passes through points -1, -2, and 1, 2. So that's one line. That's line 1, okay? Let's call that line 1. And then it says another line passes through points. We're going to call this line 2. Another line passes through points -2, 0, and 0, 4. And the question here is, are these parallel, perpendicular, or neither? So what would you have to do to determine if these were parallel, perpendicular, or neither? What do we have to do to determine that? What information do we need to know to decide if they're parallel, perpendicular, or neither? We gotta know their slopes. Technically, we probably should find their y-intercepts, but I'm gonna be okay with you just find their slopes, okay? For now. Like later on down the line, I may hammer you a little bit to find y-intercepts. But right now, if you just find their slopes and decide if they have what's parallel, what kind of slope? Same. What kind of slope is perpendicular? Opposite reciprocal. And then neither is if they're not either of those, right? So how do we find the slope of this line? What do we do? No. Rise over run, right? So change in y over change in x, right? Change in y just means we're subtracting 2 y's. So I would do this 2 minus -2. And then on the bottom, we would have 1 minus -1. Right? Hang you with me today? Okay. So 2 minus -2, that's going to be 4. 1 minus negative, that's going to be 2, right? So this slope is going to be 2. So for them to be parallel, what does this slope have to be? 2. For them to be perpendicular, what does this slope have to be? -1 over 2. And if it's anything else, they're neither, right? So I would do this 4 first. So I do 4 minus the 0. And then that means I have to do the 0 first minus this -2. So that's going to give me 4 on top, 2 on bottom. What's my slope? So what can I say about these two lines? They're parallel, right? So now, if you were given information about a perpendicular line and said, this line's perpendicular and goes through this point, you would do the same thing as we did with the parallel lines by putting it in point slope form, right? So, I mean, it's just the key here is knowing which lines are parallel by their slopes, knowing which lines are perpendicular by their slopes, and knowing that if you're looking at equations that look like, I've lost one piece of paper, equations that look like these here, right? That you have to put them in slope intercept form to be able to tell what the slope is. You can't tell what the slope is looking at that guy right there, right? You can't. You just can't. Okay? Okay, your assignment is lesson 25. You've got 2. Slopes of parallel lines, show it. Slopes of perpendicular lines, show it. 5 questions apiece. You have an interactive worksheet. I want you to do the interactive worksheet and then screenshot the whole screen, please. Not just your score. Screenshot the whole screen and post it to Buzz. What? Okay. I'm going to stop the video now.